Hello everyone. In this question we are asked to evaluate the integral of 6 upon e raised to the power 3x plus 6 e raised to the power 2x plus 11 times e raised to the power x plus 6 as x goes from 0 to infinity. Okay, so this is a definite integral and it is an improper integral as the limits are not bounded. Okay, it is open-ended from 0 to the positive infinity, that is the positive real number line. Okay, so this is unbounded or improper integral. So first of all, in the denominator I want to use one formula for factorization. Okay, so the formula is, we know the middle term of uh, two factors, that is x plus a into x plus b, is known, right? This is x square plus a plus b times x plus ab. But if there are three terms, three products here, x plus a times x plus b times x plus c, this is given by x cube plus a plus b plus c times x square plus ab plus bc plus ca times x, and the last constant term is product of this other terms. Okay, abc. Okay, so this is the formula that will be used for factorizing the denominator of the integral. Okay, you see here the coefficients are 1, 6, 11 and 6 again. Okay, so if you look carefully, the denominator can be factorized as x plus 1 times x plus 2 times x plus 3. If you write it, then the first term of this product of these three terms will be x cube plus, if you do 1 plus 2 plus 3, that is 1 plus 2 plus 3 times x square, this will give us 6x square, right? Plus this is ab plus bc, right? So this is 1 into 2 plus 2 into 3 plus 1 into 3 times x, right? And abc is 1 times 2 times 3, so this is again 6. Okay, and this gives us 2 plus 6 8 plus 3 11x. Okay, so this is the factorization of the denominator. Okay, so I have highlighted this first before starting the integral. So the integral is 0 to infinity 6 divided by e to the power, is it e to the power 3x plus 6 e to the power 2x plus 11 e to the power x plus 6 dx, right? So this on factorizing will give us the terms. Here it was x plus 1 plus x plus 1 times x plus 2 times x plus 3, right? But here this first term is e to the power x whole cube, right? And this is e to the power x whole square. So this can be factorized as e to the power x plus 1 times e to the power x plus 2 times e to the power x plus 3, right? And the numerator is 6 and the limits are as it is 0 to infinity, right? So when you expand this using this formula, you will get this left hand side. Okay, so now let us use the substitution. Say instead of e to the power x, I am using another variable u. Okay, u equal to e to the power x. So if I differentiate both sides, I'll get du equal to again e to the power x. Okay, instead of doing the derivative here, first of all, I want to break the partial fraction first. Okay, so if I write u equal to 6, u equal to e to the power x here, then I can write this just this partial fraction as, this will become 6 upon u plus 1 times u plus 2 times u plus 3. Okay, this is just the fraction without the limits of integration. Okay, I've just written this fractions. So in order to do this as a partial fraction, since there are three terms in the denominator here, the partial fraction will have three terms. So we are using three constants here, say u a upon u plus 1, the other being b upon u plus 2, and the third one being c upon u plus 3, say. Okay, these are the three unknown constants that we will use in order to split this given fraction into 3 separate partial fractions. Okay, so if we do the LCM in the right hand side, we get 6 divided by the product of u plus 1 times u plus 2 times u plus 3. This is equal to a times u plus 2 times u plus 3, because u plus 1 is there. Similarly for B, since u plus 2 is there, we will have the product of u plus 1 times u plus 3, and for C, u plus 3 will be there, so the product terms will be u plus 1 times u plus 2, right? And this is divided upon by the product of u plus 1, u plus 2 and u plus 3, right? So the denominators on both the sides of the equations can be cancelled as they are same. Okay, so this gives us that 6 is equal to a times u plus 2 times u plus 3 plus b times u plus 1 times u plus 3 plus c times u plus 1 times u plus 2, right? So in order to find the values of ABC, we try putting different values of u in this equation. Okay, so in order to get a, okay, in order to get a, if we put the value of u equal to say -1, because -1 is there in B, sorry, u plus 1 is there in B and u plus 1 term is there in C. So putting u equal to -1, u equal to -1 in say this equation, which is equation 1, say in 1, this implies that left hand side will be 6 again, and this will become a times -1 plus 2, right? So this will become 1, and -1 plus 3, which will become 2, right? So this becomes 6 equal to 2a. So this will give us a equal to 3, I believe. 6 equal to 2a, so this will give us 3, a equal to 3, right? Similarly, in order to get b, since u plus 2 is not there, so we can use u equal to -2, because u plus 2 is there in A and it is there in C again. Okay, so putting u equal to -2 in 1, the left hand side will be constant 6, and this A will vanish and this C will vanish, right? So only B will be left, and this will be B times -2 plus 1 will be -1, and this is -2 plus 3, right? So this is 1, so we get B will be equal to, this is minus B equal to 6, so B equal to -6, right? And for the last case, you see in C u plus 3 is absent, right? But u plus 3 is present in B and A. So if we put u equal to -3 in 1, we will get C. So this gives us 6 equal to C times -3 plus 1 will be -2, and -3 plus 2 will be -1, right? So this gives us C will be equal to 6 divided by this product is 2, right? 6 by 2, so this will again be 3. So we get the 3 constants, right? The 3 constants while doing this partial fraction. So our partial fractions now become 6 upon u plus 1 times u plus 2 times u plus 3. This now changes to 3 upon u plus 1 minus 6 upon u plus 2 plus 3 upon u plus 3, I believe, right? So far we have computed up to this much. Okay, so now let us look at this original integral again. So our integral, which was from 0 to infinity of 6 divided by e to the power x plus 1 times e to the power x plus 2 times e to the power x plus 3 dx. This now essentially, if we divide back to x, we had u equal to e to the power x, right? So if we rewrite this integral in terms of x again, we will get integration of 0 to infinity, and no limits won't change, right? Because we are again going back to x. So this will become 3 upon e to the power x plus 1 minus 6 upon e to the power x plus 2 plus 3 upon e to the power x plus 3, right? This is the entire integral, right? So now we have three parts here. Okay, three parts here. So for the first part, this is essentially can be split into three separate parts, that is 3 e to the power x plus 1 dx minus 6 upon e to the power x plus e to the power x plus 2 dx, and last part is 3 upon e to the power x plus 3 dx. Okay, now for each of these parts I'm using different substitutions. Okay, so again if u is equal to 3 to the 3 by e to the power x plus 1, right? So instead of doing it directly here, instead of doing the substitution directly here, it is better if I divide this numerator and denominator of this fraction by e to the power x. Okay, so if I divide this numerator by e to the power x, this first term will become 3 upon 3 e to the power minus x, or 3 by e to the power x. Okay, and this will become e to the power x by e to the power x, so this will become 1, and this will become e to the power minus x, right? I've just divided and divided both numerator and denominator by e to the power x for this first integral. Okay, 0 to infinity, sorry, 0 to infinity, yes. Then second, for the second integral also, I will again divide both the numerator and denominator by e to the power x. Okay, so this will become 6 e to the power minus x divided by 1 plus 2 e to the power minus x, and the limits are from 0 to infinity. And I will do the same for this last integral also, last part also. Okay, 0 to infinity, this will become 3 e to the power minus x divided by 1 plus 3 e to the power minus x dx. Okay, this step is clear. Okay, you can pause the video and see clearly if there is any doubt. I have just divided both this each of these numerators and denominators with e to the power x separately. Okay, so now this step is done, because now if I use the substitution separately for each of these, I am using different substitution. Okay, for this first part, for this one, if I am using u is equal to 1 plus e to the power minus x, okay, then I get du will be equal to minus e to the power minus x dx, I believe, right? So this implies, since there is only e to the power minus x dx, this implies that minus du is equal to e to the power minus x dx. Okay, this is for the very first integral. Okay, this part also the limits will change as x is going from 0 and it is going towards infinity, right? It's tending towards infinity. So on putting x equal to 0 here, e to the power 0 is 1, so this will be 1 plus 1 2, and on putting x tends to infinity, this will become e to the power minus infinity, right? So e to the power minus infinity, this term e to the power minus infinity is 0. Okay, limiting value is 0, so this becomes 0, so this becomes 1 plus 0, which is 1. This is just for this first integral. For the second integral, if I use another substitution b, and I'm again taking the denominator here, say 1 plus 2 e to the power minus x, so this gives me dv will be equal to minus 2 e to the power minus x dx, right? So on dividing both sides, since there is only here we have 6, right? So if I multiply both sides by 3, right? I can multiply both sides by 3, so this becomes 3 dv is equal to minus 6 e to the power minus x dx, right? This minus sign, if I take it inside this integral, this will become minus 6, right? So I'm using 3 db here. Okay, and again the limits will be for x equal to 0 to infinity. The value of v in this case, it is 1 plus 2 e to the power 0, so this will become 2, right? So 1 plus 2 will be 3. And again, as x tends to infinity, this term will be again e to the power minus infinity will be again 0, right? So this will be 1 plus 0, so this is again 1. Similarly, for the last part of this third part, if I take w equal to 1 plus 3 e to the power minus x, then we have dw is equal to minus 3 e to the power minus x dx, right? So there is 3 e to the power minus x, so I need to divide both sides by minus 1, I believe, right? So again minus dw will be equal to 3 e to the power minus x dx. So I believe I've got the numerator here, right? So again, now doing the limits, putting the limits in this third integral, x goes from 0 and tends to infinity, w will be 1 plus 3, right? As x is 0, this will become just 3. 1 plus 3 will be 4, and last term will be just again 1 plus 0, so this will be just 1. Okay, so the original integral, this integral, okay, on putting these values we get u goes from 2 to 1, this 3 e to the power minus x dx, we have a 3 will be left out, 3 times e to the power minus x dx will be minus du, right? So this is 3 times minus du upon, this is just u, right? U, and taking this minus inside this integral, this will become plus, right? So plus, the limits are from 3 to 1, this minus 6 e to the power minus x dx, this will be 3 dv, right? So this is 3 dv upon, this is just v, right? Just v. And lastly, for the third integral, the limits are from 4 to 1, and in the numerator 3 to the power minus x dx, this will be minus dw, right? Minus dw divided by w, I believe, just w, right? Okay, so we have computed this integral now. At least we just need to do the limits here. Okay, so for the first integral, since there is a minus sign here, I can change the this order of the limits. Okay, so this minus sign will vanish, so this first term becomes 3 times integration of du upon u, as integral goes from 1 to 2. Similarly, for this one, if I reverse the order of limits, this will become minus 3 times integration of dv upon v, as integral goes from 1 to 3. And for the last one also, on reversing the order of limits, the integral changes to 1 to 4 integral of dw upon w. Okay, so this has simplified a lot here. So this becomes 3 times ln mod u, limits goes from 2 to 1, this one becomes 3 times ln mod v, limits are again from 3 to 1, 1 to 3, and this one again becomes just ln mod w, limits are from 1 to 4. Okay, so now if we put the values of these limits here, this becomes 3 ln 2, 3 ln 2 minus 3 ln 1, but ln 1 is 0. Okay, so if you want you can write, but this term will become 0. Okay, so this is the first limit done. First part is done. Now coming to the second part, this will be again 3 ln 3 ln 3, then minus or minus plus 3 ln 1, but 3 ln 1 will be again 0. Okay, ln 1 is 0, so we can discard that and we are left with ln 4. Ln 4 minus ln 1, again ln 1 is 0. Okay, so these are the three terms we are left with. So now on taking the positive terms together, this becomes ln 8. If I take these 3 to this power here, okay, this becomes 2 cubes, so this becomes ln 8 plus ln 4 minus, if I again take this to the power of 3, this will become ln 3 cube, right? So this will become ln 27. So now ln a plus ln b will be ln ab, right? So this will become ln 8 times 4, so this will become ln 32 minus ln 27, right? So this is now ln a minus ln b, so this finally becomes ln of 32 upon 27. Okay, so this is the required final answer. Okay, this was not very difficult. It required partial fraction, but I was very slowly explaining each of these steps. Okay, while doing the partial fractions I was explaining very slowly, so I hope I was able to make you understand these steps. Okay, still if you believe there is any doubts in any steps, or there is some mistakes in any of these steps here, okay, you can highlight or mention in the comments. Okay, otherwise this is the required final answer. Okay, the options were given in this format, that's why I had to compute it this way. Okay, if it is a general subjective question, you can actually leave it up to here also, you don't need to come to this specific format of the answer. Okay, unless it is given that prove that or show that. But in MCQ, if the options are given as such, you need to compute it that way. Okay, so this is the required final answer. Okay, thank you for watching.